In the previous video, we factored this polynomial, 2x to the third minus 9x squared plus 12x minus 9, into linear and irreducible quadratic pieces. For this video, we will now factor the irreducible quadratic into linear factors with complex coefficients. We'll begin by starting from the quadratic formula. The quadratic formula says that x is equal to negative b plus or minus root of b squared minus 4ac divided by 2a. We'll look over to our irreducible quadratic, and we'll see that our a is equal to 2, our b is equal to negative 3, and our c is equal to positive 3. We place those numbers inside of the quadratic formula. We'll end up with x equals negative of negative 3, which is positive 3, plus or minus negative 3 squared, which will give us 9, minus 4 times 2 times 3. Then we divide everything by 2 times a, but 2 times our a, which is 2, will give us 4. Now we simplify the terms inside of the square root. Negative 4 times 2 times 3 will give us negative 24. Inside of the root, if we take 9 and subtract that 24, we'll end up with negative 15. Now we'll need to simplify that root. If we have root of negative 15, we can split that into root of negative 1 and root of 15. Root of negative 1 is just the letter I to show that our answer will be complex because we'll have an imaginary term. For 15, we could divide by perfect squares, like 4 or 9, but if we tried either one of those, we would not give an evenly divisible answer. This means this cannot be simplified, and we will simply write root 15. Therefore, our imaginary term will be I root 15, still divided by 4. Now we will split that into two solutions. Our first solution will be x equals 3/4 plus I root 15 over 4. Our other solution will be again 3/4, but now minus I root 15 over 4. These will be our complex roots. Now let's review our solutions. In the previous video, we found that x equals 3 is one of the roots of our polynomial. And in this video, we found our two complex roots. Therefore, we have one real root, which is positive, and two complex roots. Now to write the polynomial as a series of linear factors, we will take each of the terms from the right, move it to the other side, and change all of the signs. We will do that for our real and complex roots. Let's first look to our real answer. If we have x equals 3 and we move the 3 to the left, we'll end up with x minus 3. This will be our real factor. Then we'll have two complex factors. The first complex factor is if we start with x and then move the 3/4 and the positive I root 15 over 4, both to the left, giving us negative 3/4 and negative I root 15 over 4. Our other complex factor will still have x, it'll still have negative 3/4, but now we will have positive I root 15 over 4. The only difference between the complex factors is that the imaginary term has changed its sign. This is one of the possibilities we accounted for back at the beginning of this series. We had said previously that it was possible we could have 3 positive real roots, but it was also possible that we had 1 positive and 2 complex. We've proven that 1 positive and 2 complex was the correct answer.